Hello and welcome to the next lesson. Now that we have installed R and RStudio and have a basic understanding of how they work together, we can get at what makes R so special, and that is packages. So what is an R package? So far anything we have played around with an R uses the base R system. Base R, or everything included in R when you download it, has rather basic functionality for statistics and plotting, but it can sometimes be limiting. To expand upon R's basic functionality, people have developed packages. A package is a collection of functions, data, and code conveniently provided in a nice, complete format for you. At the time of recording this lecture, there are just over 19,266 packages available to download, each with their own specialized functions and code, all for some different purposes. For a really in-depth look at R packages, what they are and how to develop them, you can check out Hadley Wickham's book From O'Reilly, R Packages. Link will be provided in our blog post, so definitely check that, and please follow our blog post too. Let alone watching these lectures won't help much. You will have to read and practice what we provide along with these lectures. So a package is not to be confused with a library. A library is the place where the package is located on your computer. To think of an analogy, a library is just a library, and package is like a book within the library. The library is where the books or packages are located. Packages are what make R so unique. Not only does base R have some great functionality, but these packages greatly expand its functionality. And perhaps most social of all, each package is developed and published by the R community at large and deposited in repositories. So what are repositories? A repository is a central location where many developed packages are located and available for download. There are three big repositories. First, CRAN, Comprehensive R Archive Network, R's main repository, which has more than 18,000 packages available. Second is Bioconductor, a repository mainly for bioinformatic focused packages. Third is GitHub, a very popular open source repository but not R specific. Take a second to explore the links to these repositories that are provided to you in our today's blog on R packages, and check out the various packages that are out there. So you know where to find packages, but there are so many of them. How can you find a package that will do what you are trying to do in R? There are a few different avenues for exploring packages. First, CRAN groups all of its packages by their functionality or topic into 35 themes. It calls this its task view. This at least allows you to narrow the packages you can look through to a topic relevant to your interests. Second, there is a great website R documentation, which is a search engine for packages and functions from CRAN, Bioconductor, and GitHub. If you have a task in mind, this is a great way to search for specific packages to help you accomplish that task. It also has a task view like CRAN that allows you to browse themes. More often, if you have a specific task in mind, Googling that task followed by R package is a great place to start. From there, looking at tutorials, vignettes, and forums for people already doing what you want to do is a great way to find relevant packages. Now, how do you install packages? There are many ways to install a package. If you are installing from CRAN repository, use the install.packages function with the name of the package you want to install in quotes between the parentheses. Note, you can use either single or double quotes. For example, if you want to install the package ggplot2, you would use install.packages, parentheses, quotes, ggplot2, quotes closed, and round bracket closed. Try doing so in your R console. This command downloads the ggplot2 package from CRAN and install it onto your computer. If you want to install multiple packages at once, you can do so by using a character vector like install.packages, round parentheses, C for concatenation, again round parentheses, first package name between quotes, followed by another package name between quotes, and so on. If you want to use RStudio's graphical interface to install packages, go to the tools menu and the first option should be install packages. If installing from CRAN, select it as the repository and type the desired packages in the appropriate box. The bioconductor repository uses their own method to install packages. First, to get the basic functions required to install through bioconductor, use source function with the link to the bioconductor repository, which is bioclite.r. This makes the main install function of bioconductor bioclite function available to you. Following this, you call the package you want to install in quotes between the parentheses of the bioclite command, just like in the slides. Next is installing from GitHub. This is a more specific case that you probably won't run into too often. In the event you want to do this, you first must find the package you want on GitHub and take note of both the package name and the author of the package. I will provide the link to the guide for installing from GitHub, but the general workflow is like install.packages parentheses and DevTools between the quotes, followed by library parentheses DevTools, install GitHub function with author and package name, just like in slides. Now you have installed a package, but installing a package does not make its functions immediately available to you. First, you must load the package into R. To do so, use the library function. Think of this like any other software you install on your computer. Just because you have installed a program doesn't mean it's automatically running. You have to open the program. Same with R, you have installed it, but now you have to open it. For example, to open the ggplot2 package, you will run library parentheses ggplot2. One important thing to note here, do not put the package name in quotes. Unlike when you are installing the packages, the library command does not accept package name in quotes. There is an order to loading packages. Some packages require other packages to be loaded first, which is called dependencies. That packages manual or help pages will help you out in finding that order if they are picky. If you want to load a package using the RStudio interface, in the lower right quadrant there is a tab called Packages that lists out all of the packages and a brief description as well as the version number of all the packages you have installed. To load a package, just click on the checkbox beside the package name. Now once you have got a package, there are a few things you might need to know how to do. Checking what packages you have installed. If you are not sure if you have already installed a package or want to check what packages are installed, you can use either of install.packages function or library function with nothing between the parentheses to check. In RStudio, that package tab introduced earlier is another way to look at all of the packages you have installed. You can check what packages need an update with a call to the function all.packages function. This will identify all packages that have been updated since you installed them or last updated them. To update all packages, use update.packages. If you only want to update a specific package, just use once again install.packages function with the package name inside the parentheses between quotes. Within the RStudio interface, still in that packages tab, you can click update, which will list all of the packages that are not up to date. It gives you the option to update all of your packages or allows you to select specific packages to be updated. You will want to periodically check in on your packages and check if you have fallen out of date. Be careful though, sometimes an update can change the functionality of certain functions. So if you rerun some old code, the command may be changed or perhaps even outright gone, and you will need to update your code too. Sometimes you want to unload a package in the middle of a script. The package you have loaded may not play nicely with another package you want to use. To unload a given package, you can use the detach function. For example, detach, like I used the detach function in the slides. That would unload the ggplot2 package that we loaded earlier. Within the RStudio interface, in the packages tab, you can simply unload a package by unchecking the box beside the package name. If you no longer want to have a package installed, you can simply uninstall it using the function remove.packages like I used in the slides. Try that, but then actually reinstall the ggplot2 package. It's a super useful plotting package. Within RStudio, in the packages tab, clicking on the cross at the end of a packages row will uninstall that package. Sometimes when you are looking at a package that you might want to install, you will see that it requires a certain version of R to run. To know if you can use that package, you need to know what version of R you are running. One way to know your R version is to check when you first open R or RStudio. The first thing it outputs in the console tells you what version of R is currently running. If you didn't pay attention at the beginning, you can type version into the console and it will output information on the R version you are running. Another helpful command is sessioninfo function. It will tell you what version of R you are running along with a listing of all of the packages you have loaded. The output of this command is a great detail to include when posting a question to forums. It tells potential helpers a lot of information about your operating system, R and the packages, plus their version numbers that you are using. In all of this information about packages, we have not actually discussed how to use a package's functions. First, you need to know what functions are included within a package. To do this, you can look at the help pages included in all packages. In the console, you can use the help function to access a package's help files. Try help function just like I did in the slides, and you will see all of the many functions that ggplot2 provides. Within the RStudio interface, you can access the help files through the packages tab again. Clicking on any package name should open up the associated help files in the help tab found in that same quadrant besides the packages tab. Clicking on any one of these help pages will take you to that function's help page that tells you what that function is for and how to use it. Once you know what function within a package you want to use, you simply call it in the console like any other function we have been using throughout this lesson. Once a package has been loaded, it is as if it were a part of the base R functionality. If you still have questions about what functions within a package are right for you or how to use them, many packages include vignettes. These are extended help files that include an overview of the package and its functions, but often they go the extra mile and include detailed examples of how to use the functions in plain words that you can follow along with to see how to use the package. To see the vignettes included in a package, you can use the browse vignettes function. For example, let's look at the vignettes included in ggplot2. Use the browse vignettes function like I did in the slides. You should see that there are two included vignettes, extending ggplot2 and the aesthetic specifications. Exploring the aesthetic specifications vignette is a great example of how vignettes can be helpful. Clear instructions on how to use the included functions. So in this lesson, we have explored our packages in depth. We examined what a package is and how it differs from a library, what repositories are, and how to find a package relevant to your interests. We also investigated all aspects of how packages work, how to install them from the various repositories, how to load them, how to check which packages are installed, and how to update, install, and unload packages. We took a small detour and looked at how to check what version of R you have, which is often an important detail to know when installing packages. And finally, we spent some time learning how to explore help files and vignettes, which often give you a good idea of how to use a package and all of its functions. If you still want to learn more about R packages, I will provide two great resources: R Packages Beginner's Guide from Adolfo Alvarez on DataCamp and a lesson from the University of Washington on an introduction to R packages from Ken Rice and Timothy Thornton. I will provide those links on my blog post for this lecture. See you in the next lecture.